All right, so as you see, it's chapter 5, and like I just prayed, let's get a good start with this, okay? And most of you guys have been doing pretty well, but some need to really start off well. So let's make sure we do all the homeworks again, which most of you guys are doing. I've got other classes where that's not the case, okay? But most of you guys are doing all your homework, which is good, and that really shows on your grades. It really does. So anyway, enough of that. Circumcenter and Orthocenter. So there's actually, I think there's 5 different things that we're going to do, but they break them up into a couple different sections, all right? So here's the first one. This one's a real popular one. This Orthocenter thing right here. We're going to use it. We're going to talk about it, but there's really not a whole lot to say about it. So today, really, we're going to concentrate on this thing, the circumcenter. But before we do that, we are going to talk about, let's see, what do they call it? This is a theorem, okay? I thought it might be a definition. But this first thing we're going to talk about is a theorem. So let me go to this new program. Let me bring this up. Now I got to switch this thing over right there. All right, now it's recording that new program. All right, that's what it looks like. So the program, I'm not used to using this pen with this program, so I'm just going to use the mouse pad. Let's move this over. It's called GeoGebra. Do you see that at the top left? You can't see it at the top left. The screen cuts it off. But it's G-E-O. Let's see if I can move this over a little bit. There we go. GeoGebra. See? It's GeoGebra, which is kind of a funny name. But why do you think they call it GeoGebra? Because it's between what and what? Algebra. Yeah, it's between geometry and algebra. And they have a whole thing on here. See this thing where you click on algebra and you can actually type in an equation and it'll graph it for you and all that kind of stuff, okay? And I'm sure you can do a lot more stuff. I really don't know the algebra part of this, but anyway, there you go. You don't really need to see all that, so I'm just going to slide that up to the top. Yeah, sorry, the projector doesn't show the whole entire thing. All right, well, let's do this. What we're going to do is take a look at the first theorem. Do you have your books open? It's on page 206, section 5.1, and it says a theorem, and you start right off with the theorem. It says, a point lies on the perpendicular bisector of a segment if and only if it's equidistant from its endpoints. Like, what in the world was that? Well, let's take a look at the first part. It says a point lies on the perpendicular bisector of a segment. Well, let's put a segment first. You can't see it up there, but I clicked on this little thing called segment. And so watch, if I click here and I click here, let's put it about right there. Yeah, so there's a segment. And what I'm going to do, it's got a beginning and it's got an end. All right, so it doesn't keep on going. It's got the points at the end, A and B. I want to find the perpendicular bisector. What in the world does that mean? I don't think, have we talked about that in here? They just kind of throw it out there right in the theorem. But we can figure it out. It's pretty easy. It's perpendicular. So what does that mean? We're going to have a 90-degree angle, exactly. And it's a bisector. So if we bisect the segment, where are we going to hit it? In the middle, or give me a better geometry word. Nah, give me a geometry word. The midpoint, okay? So I actually have a, I got to hit this. Actually have a thing that, and again, you can't see it on the screen, but it's over there on the left-hand side of my program. If you watch the video, I think it'll show it on the video. It says midpoint. So what I do is I click the midpoint button, I just click on this line right there, and bam, it puts midpoint right there. Pretty cool, huh? And it's exactly the same distance from A as it is for B. Now, I want a perpendicular line as well. So what I'm going to do, this does have perpendicular, but the line keeps on going. I'm just going to do a segment. I figured out how to do this. And what I'm going to do is start here, and then if I hit the Alt button, see, watch, if I'm off to the side, it goes crooked, but if I hit Alt, let's see. See how it's nice and straight right there? All right. Now, unfortunately, it doesn't show the little right angle mark on here. I tried to figure out if you could. I don't think it does. All right. But that's a right angle. Everybody with me? And it hits the midpoint. So what do we call that thing right there? What do we call DC or CD? We call it look at the theorem. What do we call it? 2 words. Look at the theorem. What are the 2 words? I said open up your book. Anybody got your book open? What does the theorem say? It says a point lies on the what? Very good. The perpendicular bisector. Again, why is it called a perpendicular bisector? Because this is perpendicular and it's a bisector, right? It bisects AB. Everybody see that? Hits it at its midpoint, so that would be considered a perpendicular bisector. What does the rest of the theorem say? You got your book open? Let's take a look. I'm not going to write it down because I can't like write freehand on this thing. Oh, I could do this. Let's see. And again, I'm pretty new to this program. There's a thing way down here. Yeah, watch this. So I could actually write, let's put my cursor in here. It's really not that funny. I don't know why we're laughing about this. I got to tell you, it's kind of annoying when you laugh about every little thing that I do up here. So anyway, there we go. So I can write on it, but I got to type. All right, so it's called the perpendicular. It's called the perpendicular bisector. Again, because it hits the midpoint. C is the midpoint of AB, and it's a right angle right there. All right. I don't know what that G is. What's that? Oh, I know what that is. I think it names the line segment. I don't even know why that G is there. But anyway, that's good enough. So this is called the perpendicular bisector. What does the theorem say, though? It says, if a point lies on the perpendicular bisector, so I can come up here, make a point. If it lies on the perpendicular bisector, so it could lie anywhere on here. Let's just put it, boom, right there. Okay, there's a point that lies on the perpendicular bisector. What does it say about that point? Look at the theorem. It says, a point lies on the perpendicular bisector if and only if it's what? Somebody read it to me. Equidistant from its endpoints. What does that mean? That means point E, what does the theorem say? It's equidistant from the endpoints. So what does that mean? Come on, equidistant. Okay, you can't just say, I don't know. They're both what? What'd you say?
Let's say this is 8 inches long line. It would be down the middle of the
It's equidistant. No, it's not the midpoint.
Equal to the distance.
It's equal, okay? It's equidistant from the endpoints. What are the endpoints of my original segment that I wrote, AB? It's A and B. So any point on here, I could have made that point right here. I could have made it here. I could have made it here. But that point right there is equidistant from the endpoint. So watch, if I connect it here, so AE would be equal to what? EB or BE. You see that? So those should be equal to each other if it lies on the perpendicular bisector. You with me on that? I wonder, let me see if I move this. Yeah, it does. Look, check this out. See, watch. Anywhere on this perpendicular bisector, AE and BE are going to equal each other. Do you see that? And this does another thing as well. Watch. If I just got to remember where all these things are. There's a thing that talks about the distance. Where is it? Oh, there it is. It says distance or length. I know you can't see it because it's off the screen, but it says distance or length. So now when I click that and I click this line segment right there, it tells me how long that line segment is. Now I don't know if that's like in inches or centimeters. It's some arbitrary unit. Okay, let's listen. There's nothing to laugh about. Okay, just listen and pay attention. Because one person laughs and then somebody else does and then they comment on it. Just stop. Just listen. So this distance right here, AE, is 7.2. So if I come over here and click on this one, it should be, well, it's not. It's probably because I didn't make that exactly perpendicular. Well, it was working yesterday. I don't know why. Now you could laugh because I made a mistake. To tell you the truth, if I take this, yeah, there we go. Now it's perpendicular, okay? So I don't think I made it exactly perpendicular when I first made it. So if this is the perpendicular bisector, then any point on it, because watch, if I move this down, look, the lengths are still the same, aren't they? Everybody see that? The length's the same. Even if I took it all the way up to D, the lengths are still the same, all right? Yeah, so this program's kind of cool. It shows you some stuff that I couldn't do on my other program. All right, so anyway, that's basically what the theorem says. All right, so if you believe this program is working correctly, then you should believe that theorem. Now it's a theorem, so theorems can be what? They can be proven. We're not going to do that. They do it in the book for you. Look at that proof. Okay, and again, we really haven't done formal proofs in here, and I'm still debating whether that's a good idea or not, but whatever. We haven't done them. We're not going to start now. So if you look at it, there's 13 steps to that proof, right? If you want to go through it and look at it, then that's perfectly fine. But we're not really going to do that. But this perpendicular bisector is super important because we're going to use it right now. What was the title? What was the first part of the title of this lesson? Did you write it down? Look in the book. Circumcenter. So now we're actually going to start talking about the circumcenter. But what do you think we're going to use in order to get the circumcenter? We're going to find the perpendicular bisector. Exactly right. Okay? So there's a reason why they did perpendicular bisector, because we're going to use it right now. Okay? So I'm going to draw a triangle. This is kind of cool. Watch. Just put a point here, put a point here, put a point about right there, and then come and connect them. All right? So now I got a triangle. I can move it around. Oops, oh, goodness. Let's try this again. Oh. Let's try it again. I erased it. I don't know why. All right, let's try it again. Here's one. Here's one. Let's do it about right there. And we connect it right there. Okay, there we go. So what's kind of cool about this program, watch, I can grab a corner and I can change how this triangle looks. I can move it around. I could take one of the sides and extend it out like this, move it around. So it's kind of cool. All right. I'm going to make this look more like that. Okay. All right. What I'm going to do, each of these vertices, what is the vertices is plural for what? Vertex. Okay. How many vertices do I have on this triangle? I got 3. All right. What are they? Yeah, H, F, and G. So let's move that H over here a little bit so you can see a little bit better. So H, F, and G are your vertices. So what I'm going to do is I'm going to draw a perpendicular, let me make sure. I'm not going to go from the vertex just yet, okay? I'm going to take the sides, and I'm going to find the perpendicular bisector of the sides, okay? Everybody following me on that? I was jumping ahead with the vertex thing because we are going to use the vertex in a second. So I'm going to take a look at these sides, and I'm going to make the perpendicular bisector of all 3 of these sides. So let's take the bottom one. The bottom one's the easiest one. It looks kind of level, right? Kind of looks flat. So I'm going to find the perpendicular bisector. So how do I do that? First of all, I find the what? The midpoint, and I got to... oh, there it is right there. Got to get used to this. So watch. I click on that. It gives me the midpoint. That's an I think. And then I click on this, it gives me the midpoint of that. And I click on this, and it gives me the midpoint of that. All right? Now, what do I do with these midpoints, though? I find the what? I find the perpendicular what? Bisector. So I found the bisector. Now what do I have to do? I got to find the line that is what? Perpendicular to it. That's right. So I have a you don't see it again, it's off the screen, but over on the left it says perpendicular line. I'm going to click on this and click on it again, and it makes an exact perpendicular line. Okay, now it is a line, so why does the thing keep going like that? Because it's a line, it goes forever. That's right. All right, so watch. Even if I made this smaller and smaller, that line just keeps going and going and going and going. All right, you with me on that? All right, so there is a way that I'm going to clean it up just a little bit. So now let's go to this right here. At this point, it's going to put a perpendicular line at that point. So if I click on it, right there, there's my perpendicular bisector of that side. Now, notice what those 2 perpendicular bisectors do. They meet at a point, okay? And that's not that big of a deal because almost every 2 lines would intersect each other eventually, unless they were what? Parallel to each other, okay? So any 2 lines, unless they're parallel, are going to intersect each other. So that's not that different. But watch this. Take a wild guess what's going to happen when I find the perpendicular bisector of this 3rd side. What do you think might possibly happen? It's going to intersect those other 2. That's right. So watch. If I click on this, boom, look at that. And they actually intersect inside at that one point. Okay? Now, I said inside. They're not always going to intersect inside. Actually, let's put, scroll up here. Let's put a point right where they intersect. Boom, right there. That's an L if you can't see it. we can scooch it over a little bit right there. So that's an L. This one here is an I. Let's move this over a little bit. That's a K. All right, so now you can see all the points, what they are. Okay, and you can draw this. Are you drawing this yourself?
Yeah.
Okay, now you're going to have to kind of eyeball whether it's perpendicular or not. Okay, I just happen to have this program that makes it exact. Before I use this program, I would eyeball it as well. So sometimes if you eyeball the midpoint of the three sides, you may not get it exactly at the midpoint. Would you agree? Right? Unless you're sitting there with a ruler and measuring it. Okay, but and so when you do it, you may not possibly intersect at exactly that one point, but it's probably going to be close. All right, it'll probably be very close. But if you do it exactly, it should intersect at just one point. Everybody with me so far? Okay, so yeah, we'll keep those lines on there. I was going to shorten them. There is a way I can shorten them, but it's going to take too long. I'm just going to keep going. Let's do this. I'm going to grab this. Now watch what happens. No matter, right, how I move this triangle, look what it's doing. It's keeping the perpendicular bisector of all three of those sides, isn't it? Okay? But watch this. What kind of triangle? That blue triangle right there, what kind of a triangle is that? We don't know anything about the lengths of the sides just yet, so we can't say isosceles. Isosceles means two of the sides are equal to each other. Look, are two of the sides necessarily equal to each other there? No, all right? So, but this type of triangle right here, look at the angles. What kind of a triangle is this?
A right triangle.
A right triangle? That's not a right angle. That's not a right angle. That's not a right angle. It's an acute triangle. That's right. Okay? So this is an acute triangle, which means an acute triangle means all three angles in that triangle are acute angles, okay? Well, watch what happens. You see, and oh, by the way, this right here is called the circumcenter. So let's, I'm going to, instead of calling that point L, let's actually write the word circumcenter in there, okay? It is cool. All right, so that point right there is the circumcenter. Everybody got that? This thing keeps beeping on me, so I'm going to change that. Okay, so this is the circumcenter right here. Even if I change the shape of the triangle, the circumcenter is always the intersection of the three perpendicular bisectors. Agreed? Yeah. Watch what happens when right now, this is an acute triangle. No matter how I'm making this, this is an acute triangle. But what do you think might happen if I made that into an obtuse triangle? What do you think might happen to the circumcenter? Right now, the circumcenter is inside that triangle every single time. But what if I took this angle G and I moved it down, 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 watch, until it goes obtuse. Now look at the circumcenter. The circumcenter is where on the triangle? It's outside the triangle now. So when you have an obtuse triangle, where's the circumcenter going to be? Outside the triangle. When you have an acute triangle, where is the circumcenter going to be? It's going to be inside. What if you had a right triangle?
Maybe on the line.
That's exactly right. And it's not just going to be anywhere on the line. Watch this. Now I know this doesn't really show. Actually, I could do this. Watch this. There is, I got to find it. Hold on. Don't go crazy. Just listen to me. There is a way that I can show the measure of the angle. I think it's that one. All right, and I click on here. Oh, I know what I got to do. I got to do this and this. There it goes. Look at that. And it shows me the measure of that angle. So right now, I'll put it outside so you can see a little bit better. What's that angle right now? It's 85. So still, this is an acute triangle, isn't it? All right. But watch. If I take this until it's, see, now watch the circumcenter, okay? The closer and closer I get to 90, where does that circumcenter start ending up? It moves onto the hypotenuse, okay? All right? So it's not outside the triangle. Watch this. As this gets to 90, almost there. Oh, come on. There it goes. Now, where's the circumcenter?
Right on the hypotenuse.
It's not just on the hypotenuse. It's at the what of the hypotenuse? It's at the midpoint of the hypotenuse, okay? So that's something that's kind of interesting as well. All right, so when you have a right triangle, you can still find a circumcenter, but that circumcenter is going to be right on the hypotenuse at the midpoint.
And it's also
Okay.
on the,
Everybody with me on that? See, the circumcenter's right there. It's right on it. So acute triangle, it's inside. Obtuse triangle, it's outside. And a right triangle, it's not as easy to do right there. It's on the hypotenuse. Everybody good? All right, but that's not the only thing cool about this. I'm gonna make it acute. Watch this. That in and of itself is kind of interesting. It's kind of cool that all 3 points will always intersect each other, okay? I think that's kind of interesting, don't you? I mean, I don't think that just happens, okay? I think it's created to be that way. And in a Christian school, we can talk about the creator. So who's the creator? That's right. I think this is just one little instance where things don't just happen, okay? I think it's actually designed. I think God designed, okay, this. I mean, I'm sure it wasn't a huge deal to him to design the perpendicular bisectors intersecting at one point in a triangle, but I do feel that this is a design thing. I really do. And it's just one little thing out of a whole entire universe that he designed. I think it's kind of cool. So let's do this, though. I want to, there's something about this circumcenter that is even cooler than it just intersecting at one point, okay? Watch this. I'm going to go back to my line segment, and I'm going to connect the circumcenter to the vertex. Remember at the beginning I started talking about vertex, and then I was like, I got a little ahead of myself. Now we're ready to talk about it. So I'm going to connect the circumcenter to this vertex. You're like, okay, no big deal. But I'm going to connect this circumcenter to this vertex, all right? Then I'm going to connect the circumcenter to the third vertex. And another thing that's kind of cool about this is I can click on that, click on that, click on this. Oops. All right, and watch, I can change the color of it. There we go. Now, look at those 3 red lines right there. The vertex are the corners, yes. It's where the line segments intersect each other to make the triangle. Now, look at those 3 lines right there, those 3 red lines. Are they just 3 red lines? Do they just connect the circumcenter to the vertex? What do you think might be true? And I can change the look of this thing right here. What do you think might be true about those 3 lines? Just a wild guess. Gideon? Maybe they're equal distance to each other, okay? Okay, that's a possibility. They kind of look like they're the same distance, don't they? Those red lines, don't they look like they're the same length? Yeah, they do. All right, let's see if they are or not. Got to remember where this, there it is. Okay, now watch this. If I click on the red one, that's 6.3 in this certain configuration, okay? Watch what happens. What do you think it's going to be when I click on this red one?
6.3.
Look at that. And what do you think this one's going to be? 6.3, okay? So check this out. All 3 of those distances are the same. So if you look, another theorem, page 207. It's about in the middle of 207. Are you looking at it? It's called the Circumcenter Theorem. Let's read it. Everybody looking at it? I'm not going to write it down because it's too much to write. Just look in your book. It says the perpendicular bisectors of the sides of a triangle. Isn't that what we just did? We found the perpendicular bisectors of the sides of the triangle. It says they are concurrent. What does concurrent mean? That's one of the first words we learned this year. It means they all intersect in 1 point. Okay, they all intersect. All 3 of those perpendicular bisectors intersect in 1 point. Would you agree? Yeah. But that's not all. What does the rest of the theorem say? At the circumcenter, okay, we call that point where they intersect each other the circumcenter. That point is actually the circumcenter. It says, and that point is equidistant, the same distance, right, from where? The vertices, from each of the vertices, or some people say vertexes, but it's vertices, okay? So that means that all 3 of these red lines are going to be equal to each other. I think that's kind of cool, don't you? All right. I'm going to, remember I said we are going to do a little bit with circles? Let me move this down a little bit just so that, oops, just so I don't have that other thing in the way. And let's make it just a little bit smaller so I can fit a circle in here. Now, check this out. I have let's stop, please. I'm not finished. I know you don't see it, but I'm clicking this thing. It says circle with a center and a radius. So what I'm going to do is I'm going to click, oops. I thought that you just click on it. Or maybe I click on that. So watch, click on that, and then click on that. Now check this out. I made a circle. Okay, now do you see the red lines again? Have we talked about circles in here? Oops, I don't want to do that. I don't know if we have at all, have we? Have we talked about circles? I don't think at all. Okay, but here's something about circles. We have a whole chapter on circles later on in the year, okay? But here's one thing about circles. This is something you probably learned in middle school. Shh. Let's stop the comments. So this circumcenter, forget all the other stuff in here. All those lines, okay, the triangle, all that kind of stuff. Just look at that dot right there where the circumcenter is. What do you think that is in relationship to the circle?
The radius.
Not the point's not a radius. What is it? I think I heard somebody almost say it. It's the center of the circle. Exactly right, okay? So the circumcenter, listen, and this is why we call it the circumcenter, okay? They call it the circumcenter because the radius of this circle is at the circumcenter. Center. You got it? Yeah. Pretty easy. What about circumference, right? Which is what? The distance around a circle, okay? And what do we know about the circumference? You need to know the radius, right, to know the circumference. So what are all three of these red lines? They're the radii, okay, that's plural. They're the radii of that circle. Everybody see it? And again, this didn't just happen to come together. It's not like somebody invented this. This just occurs in nature, okay? God designed it. I'm convinced of it, that God designed this. It didn't just happen. It's not like somebody just came up and made this up and say, you know what, I think I'm going to make the circumcenter the center of the circle, and I'm going to make sure the radiuses or the radii are all the same distance and perpendicular. People just discovered it, okay? They discovered what God already created, which I think is kind of cool. And so each of these red lines right there is the radius of the circle. So if you had a circle and you had a radius, can you have one circle and two different radii? No. You have a circle, you only have one radius. You got a center, and it goes to the outside of the circle. So I could draw any line from here to the outside of the circle, and it's going to be the same as that red line right there. Does that make sense? Okay, so that's why they call it circumcenter, because you're talking about circumference, which is a circle, talking about the center of the circle. And how did we find the circumcenter? What did we do to the sides of the triangle? We found the what? Two words. We found the... Come on. I even wrote it down up there earlier. You probably wrote it down in your notes. I wrote it down. What did you find on all three sides? You found the... What about the bisector? I said two words. That's one word. The perpendicular bisector, okay? Listen, we found the perpendicular bisector of all three sides, okay? So when you find the perpendicular bisector of all three sides of a triangle, they meet at one point called the circumcenter, okay? Now, what's the relationship between the circumcenter, okay, and the triangle? Well, if I connect the circumcenter to each of those vertices of the triangle, they're going to all be equal to each other, okay? And if I made a circle that goes around, and notice, all three of these points of the triangle hit that circle. Do you see that? Okay? We call this, the circle is circumscribed about the triangle. We'll talk more about that when we do the circle chapter, okay? But the circle is circumscribed about the triangle, all right? Which means it goes around, which means each of the vertices of the triangle hits right on the circle. Everybody see that? Okay? And that's what you got going on there. So that's circumcenter. We got it? Now, we're going to do like 5 of these things. Not today. We're going to do one more today, all right? But we're going to do about 5 of these things, I think. And this is the first one, so you're going to have to keep it straight. How do you find the circumcenter? You find the perpendicular bisector of the sides of the triangle. You might want to write that down. That's part of our theorem. That's what the theorem basically says. But to find the circumcenter, did anybody write that down? To find the circumcenter, you find the perpendicular bisectors of each of the sides of the triangle. To find the circumcenter, what do you find of the triangle? You take the sides of the triangle and you find the what? Perpendicular bisectors of the sides of the triangle. Okay? That's going to give you the circumcenter. Now, what's the relationship between the circumcenter and the triangle? The circumcenter is equidistant from the three vertices of the triangle. That's all part of the theorem. Okay? Both of those things I said are part of the theorem. Okay? So again, how do you find the circumcenter? Find the perpendicular bisector. What's the relationship? What's true about the circumcenter? Well, the circumcenter is the same distance, is equidistant, right? That's what equidistant means. It's the same distance from each of the vertices of the triangle. Everybody got that? Okay. Let's do another one. I got to clear this out, though, because those lines keep on going, and if I scooch it up, those lines will still be there. So I'm just going to clear all that work. It vanished. Okay, let's do another triangle. And we're going to do, what's the second thing of this lesson? Orthocenter. Now, the orthocenter, it's not as exciting because, but it's all right. It's usually the last one. The other book that I taught out of, it was the very last one they did because I think it was the least important. All right, so here's another triangle. And, oh, I forgot. I tell you what, since I'm running out of time, I'm just going to go right to it. Well, you know what? I can't. I have to keep looking at the clock. So what do I got? I got 5 minutes, only 5 minutes. Let's do this super quick. Watch this. Let's talk about a word. It's called the altitude. Okay. When you think of altitude, what do you think? You're in an airplane and the pilot gets up there and says the altitude is whatever feet, right? Would you agree? So what if I had a point, oops, let's do this. What if I had a point right there? Pretend that's our airplane, this is the ground, okay? Where are they measuring the altitude from? From the airplane, do they measure it to E? Do they measure it to D? Straight down, but give me a geometry. Perpendicular, okay? It's not bisector. Doesn't have to be bisector, okay? Listen, does not have to be bisector. It just has to be perpendicular to the ground. Would you agree? So if you're in an airplane and they say our altitude is, 20,000 feet, they do. Okay, so the airplane's going right there and they tell you the altitude. It's the straight down distance. It's the perpendicular distance to the ground. It's not bisector, it's just perpendicular. Everybody got it? That's altitude. So what we're going to do is we are going to find the altitude of the triangle. So, and we're going to go from each of the vertices. Let me figure out how to do this. There we go. Okay. So what I'm going to do is I'm going to go from a vertex, but I'm going to find the altitude. And so I'm going to hit perpendicular line. If I click this point right here and I click this line, guess what it's going to do? It's going to give me a line that is perpendicular to this line from that point A. So if I click on that, bam, there it is. You see it? It's from A and it's perpendicular to that. Everybody with me on that? So now, if I go to point C, and then I click this line right here, it's going to make a perpendicular line from C to this AB. There it is, right there. That's perpendicular. Now, guess what else I'm going to do? I'm going to start from B, and I'm going to go perpendicular to the other side. Now, guess what possibly could happen with these three lines? They intersect. What's the word that means when you have two or more lines that intersect each other? Concurrent, okay? So we're going to have concurrent lines. And if you look at the theorem, they use the word concurrent. So you need to know that. That was one of the very first words we learned in this class this year, okay? Just means they're equal to each other. They're the same. So watch, if I click this line right here, look what it does. Now look at that. They all intersect at the same point. And how did we find it? We found the altitude of all three vertices. Okay, so we started from one vertex and we went perpendicular to the opposite side. That's the altitude. Okay, We went from this vertex perpendicular to the opposite side. We went from this vertex perpendicular to the opposite side. And did they just happen? Is it just the way that I drew that triangle? Why they intersect at that one point right there? No. Okay, look, I could do this all day long, right? And they intersect, right? Now, if I made this a right angle, guess what? They intersect. They don't intersect at the midpoint, though, but they intersect at one of the vertexes, or one of the vertices, okay? If I make it obtuse, okay, where do you think they intersect? Outside it, okay? Now, remember how we said on the circumcenter, the distance from the circumcenter to each vertex was the same?
Yeah.
There's nothing true about this orthocenter, okay? There's no relationship between the orthocenter and any of the vertices, any of the sides. They just intersect each other, and that's it, okay? Not as exciting as the circumcenter, but that's basically it, okay? So that's orthocenter. I didn't write it down. I'm out of time, so you could write it down. Write orthocenter. Again, how do you find the orthocenter? You find the altitude of each of the three vertices, okay? So from that point, perpendicular to the opposite side. Here's our airplane. Here's the ground. This is perpendicular. That would be the distance. Everybody got it? Okay. Let's do this. Let's go back to Illustrator. And, let's see. Do you have your lesson plan thing in front of you? Let's see what your homework was. So it looks like I gave you, I split this up into two parts. I'm not really sure why, but I'll just stick with it. So here's your homework, section 5.1, and it's pages 209 and 210. And you're doing just 1 through 7. I don't know why I made it so easy, but I did, so I'll stick with it. That's your homework right there. All right.